Let's think about this idea of equilibrium a little further. Consider this equation. CO gas plus Cl2 gas is in equilibrium with COCl2 gas. Let's write an equilibrium constant expression for that. Kc equals the concentration of the product, COCl2, over the concentration of CO times concentration of Cl2. You'll notice the coefficients of all these are 1, so the exponents here are all 1. And that happens to equal 4.56 times 10 to the 9th. By the way, you'll notice there's no unit here. Values of K are in fact unitless. Let's think about what this number means, though, this 4.56 times 10 to the 9th. If you think about this as a fraction, the fact that this is a big number must mean that there's more of this than there is of these guys. In contrast, let's think about this equation. C6H5NH2 aqueous plus liquid water is in equilibrium with C6H5NH3 plus, also aqueous, plus OH minus aqueous. When we think about the K for that, this is what we're going to get. That Kc equals C6H5NH3 plus times OH minus, concentrations obviously, over the concentration of C6H5NH2. And that happens to equal 4.3 times 10 to the negative 10th. Look at how small that number is. That must mean there's a heck of a lot more of the denominator than there is the numerator. Okay? So both of these equilibria are situations in where the products and the reactants in equilibrium are not equal. If you think about the girl and the boy and their beakers, in this case, the beaker containing the products is a heck of a lot fuller than the beaker containing the reactants. Now remember, that's just an analogy. In reality, of course, they're all in the same beaker. It's just that in that beaker, there's a lot of this and a very little bit of this. And over here in that beaker, in which this whole reaction is happening, there's very little of this and a heck of a lot of that. And that is in fact true in general. If K is much, much greater than 1, the equilibrium lies to the right. There's a heck of a lot of products. The products predominate. Okay? K much, much greater than 1, there are more products than reactants. If K is much, much less than 1, the equilibrium lies to the left, and the reactants predominate. There's more reactants than there are products. Some more cute stuff we can do with equilibrium. Let's go back to this equation. N2O4 is in equilibrium with 2 NO2s. Now once again I can write a Kc, concentration of NO2 squared, over the concentration of N2O4, and I look up somewhere that that's equal to 0.212 at 100 degrees Celsius. What if, though, I write it the other way? What if I write 2NO2 is in equilibrium with N2O4? That's really the same thing, only this time my Kc is the other way. N2O4 concentration over NO2 squared. And naturally that means that the K, the value of K, is the reciprocal of what it was before, because this is the reciprocal of that. So this K and this K are reciprocals of each other. And that is absolutely and always true. If you write the reaction in the other direction, and you knew this K, you also know this K. They're reciprocals of each other. It's also true that if I write 2N2O4 in equilibrium with 4NO2 solid, you'll note that's double this guy, N2O4, 2NO2. Now I've got 2N2O4, 4NO2. Now Kc is NO2 to the 4th power over N2O4 squared, which is the old K squared. The value is 0.212 squared, or 0.0449. Once again, that's always true. If I multiply the reaction by a coefficient, then the new K is the old K raised to that coefficient's power. I can even extend this. If I have this equation, 2NOBr is in equilibrium with 2NO plus Br2, I can write a Kc for that, NO squared times Br2 over NOBr equals 0.014. And these values I'm just looking up. There's huge tables of them. And then I have another one, which is Br2 plus Cl2 is in equilibrium with 2BrCl. There's my Kc, concentration of BrCl squared, over concentration of Br2 times concentration of Cl2, and that happens to equal 7.2. Well, suppose the equation I want to know the K for is the addition of these guys. I could add these up just like I add up simultaneous equations, just like I was adding up elementary reactions over in kinetics. The Br2's cancel out, and I've got 2NOBr plus Cl2 in equilibrium with 2NO plus 2BrCl. Now the K for this is concentration of NO squared times the concentration of BrCl squared over the concentration of NOBr squared times the concentration of Cl2. Well, look what that is. That's the K I had before times this other K I had before. It's this guy, 7.2, times this guy, 0.014. And that's how I know what the new K is. 0.014 times 7.2. That always works.